Hi there, Alcard J here with a couple of additions to the Slender guide. Okay, a question came up as I was uploading the first video actually, how to make my enemy move faster as each paper is collected. And that's a decent question, so I thought everyone would like to know that. Okay, so where does things happen when we pick up papers? Okay, so we picked up a paper here because we're incrementing it. Okay, when we don't have any papers and we pick up the first one, we start the enemy moving. So the enemy's speed is set to 0 at this point anyway, so we don't need to modify anything here. So every time we pick up a paper, pretty much, except for the first, well, exactly, the first time, and every time after that we're calling this function, the enemy reduced distance. Okay, so what happens over there? Here we are. Okay, so as you know from making the game along here, reduce distance, every time you pick up a paper, the enemy will start following you at a closer distance. So it gets closer and closer if you turn around. Okay, this seems like a perfect spot to add the speed. I mean, if he's getting closer, he's obviously making a change. So we'll add some speed in here too. Now, first we need a variable to define how much we're going to change speed by. So currently it sits at 5. So we want to bring up a little bit each time. Make it a public so you can change it. Public bar speed increment float of type float. Let's give it 0.8 and see what happens. Okay, so this is going to act every time we want to increase speed. We're going to be increasing speed by this amount. So it's going to be quite linear. So once this is fixed, it's fixed. But if you play with the value, we get something that will feel right. So we're going to be using speed increment. When we reduce the speed, reduce the distance. Okay, we're changing the speed. Speed, but we're adding to the speed. So we're adding to what is already speed. And what are we adding to it? The speed increment. Okay, so every time a paper is picked up, reduce distance is called. Of course, he continues reducing distance, but now we just add a little bit to his speed. So he does get faster as we move each time. Alright, we can just quickly test that. Compile out. Let's watch the enemy. And we are watching the speed variable here, set to 5. Okay, I'll hit play. Of course, he is in range, so even though it says 5, he's not moving, as you can see in the scene view at the top. So I should pick up the first paper and make it happen. Okay, the first paper is up. And it looks like he's even teleported. So the speed is 5, because like nothing changed. He went from 0 speed to 5 speed. Let's pick up the second one. 5.8. So that 0.8 has been added to the 5. So we've wandered around a bit. We picked up another one. 6.6. So there we go. The 0.8 has been added twice now. That's correct. With 3 papers. Okay, so you can see how that's starting to happen already. Here we go. 8.2. So he's now as fast as us. 9. See, so again, you probably have a higher starting value anyway, but or even if you leave it at 5 and change the speed increment to 0.1, I think my answer I actually gave him 1.25. I thought, okay, he's coming. But there we go, that's the first part. I said there was another addition. At the moment, if you've played it, you can see you have a world, but there's no limitations to the world for your player, so your player can quite easily walk off the side of the world. We don't want that. I mean, that's not a great experience. So what we're going to do is we're going to check the position of the player, the transform position, and then we're going to compare it to some variables that we set up that define our space in the world. So, yeah, see, looking at this player character, there really isn't anything that defines the player. There's nothing that says player script. It's another example of how that can be done so much better. Alright, so at the moment, the only thing we have that calls update every time is collect papers. This could essentially be the player script at the moment, because it's got most of the user functionality on it. Okay, so every update, we're also going to want to check that our player is still within the confines of the world. So, what we're going to do, we're going to clamp player to world. Okay, and we'll become clear in a moment. Just make a function that is already calling that doesn't exist. Great, so that might error out now. We've got a call, we've also got a function. Okay, so we want to clamp to the world. Okay, so first looking at our world, I could just go into details about how to go into the terrain data, of the terrain, and look at all these variables and things, but there's one here. If we have a look, we can see the resolution of our world. Okay, the width is 512, so mine's positioned at 0, 0, and that would be 512. And for the length, because remember this is 3 dimensions, so your y is actually, that's the 300 in height there. Okay, so your length is the z-axis, so the same, it's 512 by 512 square terrain, half a kilometre, roughly. Okay, mine's positioned at 0, 0, but some of you may have your terrain centered, or even offset, or something like that. I mean, I assume it's either going to be at 0, 0 or centered. Hopefully, the rest will be confusing to do this part. Alright, so we need some variables so we can hold and remember those values. I said I could make a script that searches for those values, but at the moment I just want to clear things up quickly with about 5 lines of code. Alright, so we're going to make it public because we need this to be adjusted in the inspector, absolutely. Public var world width. Okay, now what I'm going to do, I'm going to make it as a vector 2 because essentially I want to remember 2 values for width. Okay, I want to remember the left hand side in world space and the right hand side in world space. So I'm going to make this a vector 2. Okay, now 2. Let's have a latent pinky on the shift. Alright, so vector 2 I already determined for myself. My world is at 0, 0. Okay, then the left hand side of my width, the x, is on 0. So I can quite happily put 0 my x value, which is going to represent my left. See what I'm using a vector 2 for? Left is the x, and the right is the y. So speaking of the y, I'm going to say that's the full width from 0, which is 512. Like I said, if your terrain is centered, you're going to be starting with an x of minus 256, or if you use 2 kilometers, you'll probably use minus 1,000 to plus 1,000. But you see what I'm trying to say? You have to tell it in world space, where it's x and its y, x and its z. So be careful with that, dealing with x and z axes. Alright, so back to collect paper. So I said 0 and 512. And similarly, for the world length, those values are both the same for me, because I start on the 0, 0 on the z, and to 512. I add the 512 for the length. Fantastic. Alright, let's save that out, see what's happened. First of all, we'll click on our player, so we can see collect papers and what variables have been added. So there's our vector 2, vector 2, and there we have it. So I've said my x on the left is set to 0, and I've said my world width is the y value, which is 512. Alright, so I've got some values that I can compare my player's position to and say, well, if I'm getting close to that 0, I want to stop moving any further in that direction. And that's the direction we're heading in. Okay, so I hope that part's clear. And what we're going to do is, as I said in the function name, we're going to clamp. So we'll read up a bit about clamp. Okay, clamp's a value between a minimum float and a maximum float. Okay? That's just like putting it in a vice in a pair of pliers. If something wants to be 8 big, and you can squish it down. But anyway, let's just see it in action. It's better than me explaining it. Okay, so we have map f clamp. So we have one more thing we need. We're going to be constantly checking our transform of our player. So we better store a reference to that, just so we've got it for quick reference. We don't be accessing transform externally all the time using the transform. We'll store it locally. So we'll make a private, because we can do all this within script, var my transform That is of type transform, because we want to be playing with the position variable of the transform. And because this is private, we know we can assign it ourselves. My transform equals this transform. Okay, done. So now, anytime we want to see where we are in our position or our rotations, we just call my transform instead of saying, hey, let's check out a game object and then the dot transform component. It takes a little bit longer to cache. Alright, so we have my transform. What I'm going to do with my transform, I'm going to clamp it to our world width and our world length. So my transform position x, so we're going to be working in the left and right first. Okay, equals map f dot clamp. Okay, that tells us our conditions here again, reminds us value is a minimum. A value that we want to clamp. Okay, so we input that first, and then all that would be, let's start it off. This is the value we're using. My transform position x, and then a minimum value because we're working in our world width. Okay, so we've got our world width x, and then our maximum value, which is world width y. And there it is. This whole function, this one line, does everything for us and stops us falling off the world. Okay? But even looking at that, you see it's going to take us right to the very edge of the world because of those numbers we set. Now, we can keep changing with this, but we might want the full size values for some other calculation. So what we'll do, we'll give it a world edge margin. And this will be a float. And what we'll put in here is a value just to say, okay, we want to come in from the edges of our limits of our world. We want to come in a bit at this value. So let us set it to about 40, or maybe you can get away with 25. What your consideration here is if you don't want to break the theme of the game, you can set it back a bit so that the trees are still there and there's some kind of occlusion that's not showing the fact that the world suddenly drops off and disappears, or you can just see skybox, no mountains, no nothing, just to not feel like you actually have reached a limit. Alright, so that's what we're going to do. World edge margin, there's that. Alright, so back to our clamping. So what are we going to do if we're clamping it here? So that's our minimum limit. So we want to be plus our minimum limit, because we don't want to go less than our limit. So we want to stop before we get to our limit. Now on the y, we want to stop before we get to the y. The y is further, so it's the y minus our margin. Okay, so we're not going to reach our margin because the margin is going to bring the world y width back down to here. Alright, I'll spit it out. Okay, so we've clamped the x theoretically. First of all, it's pretty much the same thing for the y, isn't it? Except for a couple of things. First of all, we are modifying the y, and we are using the y as our input value. And we're not working with width now, we're working with length. We still see we have the x and the y for our minimum and our max values for world length. So we can quite happily keep that by logic. So we're using in our y, world length. Alright? And the margin is the same up, down, left, right. I've just set one, so it's going to be one square value from the edge of the world. Okay, so let's save that out. Just check I've got everything in place. So we've got a reference to our transform, and we pick up the reference to our transform. Every update, we want to make sure we're clamping. Our clamping is using our reference and our inspector set world values. I said you saw me do it in hardcode. As you can see, that the values are quite happily here to modify. Alright, so let's hit play and see what's happening there. Okay, that edge looks like the furthest there. I did soup up my run speed just a little bit so we can get there quicker. Okay, you see I'm floating in the air. Something's obviously very going wrong. And I know exactly what's happened even before I find it out. I said don't mix up your X, Y's, and Z's, and hopefully you saw me do it. We're dealing with an XZ plane. Okay, I've decided to clamp it on the Y. I said, okay, once you jump, you can't drop down. So, oops, let's go and fix that. So we're dealing with the Z axis. Alright, world length, because that was world length. Z. Right, that's an obvious mistake. So hit play. Where we're going in the XZ. Alright, so we seem to hit an invisible wall. We can still see the edge of the world over there, so you can see what I mean about things just dropping off and disappearing. Okay, but that's obviously clamped. You can quickly test that too. Because in runtime, it uses this variable every update, so let's drop that all the way down to 5. We'll continue. Let's see if we can get any closer. Yes, we can. Okay, but what? That must be about 5. You can see I can run along this whole wall. Can't get any closer to the edge. Alright, well, I'm near the bottom. Let's quickly try one. On the Z this time rather than the Y, and you see the bottom out there on 5. Alright, do I should teleport him to all the other places? Just to see if it works. Okay, he's just suddenly dropped in this part of the world. Okay, that wasn't a tree. We can see the flash. Okay. Of course, this is still the same. Yeah. Last, I guess we'll come up and check this up as a corner. That's a long way to drop it. Let's go. Okay, and we're checking the north. There we go. See the little grass, see the edge of the world there. But I cannot fall off. And that is your player character clamped. The enemy doesn't need such. So actually, there you go, that's enough for you to work on with. I'll leave you with that. See you on the next one.